and we also don't use the clouds, not using the database, but using the
Cool. Hey guys. So welcome to the second Apache Beam meetup here in London. Thanks all for coming. It's a pleasure to see some new faces and some recognizable faces. So I'll quickly reiterate why we are here. So we want to share some experience and some enthusiasm for the technology that Beam is. We want to learn from some experts, the speakers we invite, and from each other. If you have problems, we can discuss and learn from each other. Obviously, we want to inspire people to use Beam and to share their use cases. And in the end, we want to build a community around Beam. So, who in the room is actually using Beam? I know I asked this question last time, but it's good to have some more data points. That looks good. Yeah, and people using it in production already? Cool, yeah, that's a bit less. So, who would think of themselves as a Beam expert? Or who would like some more information and maybe a hands-on session? Hands-on sessions? Yeah. Cool. So yeah, that's good to know. It gives a bit of feedback to know how to work with the community. I want to thank some people tonight as well. I want to thank Qubit for the place, the drinks and the food. I want to thank Google for support, Datatonic for setting up and sponsoring the meetup, and Talent for sponsoring JB's talk. So let's move on. A small update from the community. I won't take too much of your time. But today we had a suggestion to launch a hashtag from the community, which is great. So if you're tweeting tonight anything, please use Apache Beam London. It would be cool. I strongly advise you to sign up to either dev, the user, or both mailing lists to stay up to date with the latest things happening in the Beam community. And then
just one thing on this side: if you are a real user, please use user mailing list.
Dev is quite technical.
Dev, sometimes you subscribe as a dev because you think you dev on Beam and it's fine, but dev is more for the internal discussion of the Beam developer community. So if you are a user, even if you are a developer user, then please use the user mailing list. Sorry, it's
no, it's fine. Great feedback. So I want to do a shout out to Griselda from Google as well. She's kind of trying to build a community around Beam as well. She's helped a lot. She's actually writer of the Beam newsletter, which you can find the URL here. I'll share the slides later. So if you want like a nice digest of what's happening in the community, that's the place to go. I want to ask you guys as well if you have any cool use cases to share. I don't know if anyone has a cool use case right now. So anything, if you have a talk you want to do here, share with us. Just contact me or Victor, he's probably upstairs. And if you have a blog post, you can contact Chris. You can be featured on the Google blog, which has quite a big reach, or on the Beam blog, depending where you probably run your Beam pipelines. And then I want to dig into the next Beam meetup as well. Victor and I had the idea to do a more practical session, to maybe do a code walkthrough, maybe some code development. I don't know if you guys would be interested in this. Somebody interested? Cool, awesome. And we were thinking of something like a come with problems and leave with answers session as well. So if you have problems facing writing Beam code, or you want to do something and you don't know yet how to do it, we could try and solve those problems as well. So the people tonight here, I'll first introduce myself. I'm Matthias, data science consultant at Datatonic. Datatonic is a consultancy firm mainly using Google Cloud Platform to do data engineering, data science and machine learning. So if you have any problems with that, please reach out to us. Victor, who is not in the room, but there are some more Qubit guys over there. He's a software engineer at Qubit, and Qubit uses the power of data to bring your company closer to your customers. So if you have problems with that, please reach out to these guys. And then we have two speakers tonight, Vadim and JB. Vadim is co-founder of FeatureFlow. He's going to talk about a use case in finance using Beam. And then JB will do a bit of the deep down technical talk about I/O in Beam, and he will talk about splittable DoFns as well. So to have a bit of context, Vadim is future flow. He's actually talking in Hong Kong. Was it? Yes. Hong Kong later this month. So if you're in Hong Kong, by any chance, you can go and watch it again. Future Flow was one of the 24 finalists. Was it 24 finalists? Or one of the 4 finalists for the Accenture FinTech Innovation Lab. So that's quite cool. But I'm sure he will be better one to talk about Future Flow. And then we have JB, who is one of the 3 top committers to the whole Apache Foundation last year. So I don't think that needs much more introduction. He's also part of the PMC at Beam, so he knows what he's doing. And yeah, this is the agenda for tonight, but I'll just give the stage to these guys and we can kick off. Thanks.
Hi guys, thanks for coming today. My name is Vadim. I'm the co-founder of Future Flow. I'm just going to set this so that I don't lose track of time. So at Future Flow, we're developing the software that aims to track the movement of money in the financial system. To put it very simply, we're trying to build a system that will help us to understand how money moves across accounts of either the same bank or across potentially multiple banks. To give you kind of the simple intuition behind what we're trying to do is if we have a transaction between 2 parties, let's say party A and party B for £5, in our system we want to represent that amount 5 as a collection of 5 distinct elements, each of which collectively represents that 5, and we want to track how these elements, or units as we call them, move around the economy as they're being used in transactions, as they exchange hands. And we want to build histories of how these units move around. We see many use cases for this technology, having to do with consumer analysis, economic activity analysis, etc. But the most urgent and interesting use case that the industry, the financial services industry, seems to want us to explore is money laundering and electronic financial crime. Just to give you some quick stats on the magnitude of the problem and why everybody's so interested in it, this problem is usually referred to as a $1 trillion a year issue. So the global illicit flows are estimated, this is by the way the conservative estimate, at around $1 trillion a year, and usually less than half of 1% of that amount ever gets tracked by the authorities. If we try to bring this problem a little bit closer to home, the UK share of those flows is about $25 billion a year equivalent, and UK banks collectively spend about $5 billion a year trying to fight that problem. And then if we apply that statistic of less than half of 1% ever gets tracked, then we conclude that UK banks spend $5 billion to deal with a $25 billion a year problem, and yet they catch only 50 million. Right, so criminals seem to be winning by a wide margin. And of course, this is a very significant problem with very complicated and deep root causes. Some of them go right down to the structure of our societies. By the way, if some of you are watching McMaffei on BBC right now, you probably know what I'm talking about. If not, I highly recommend it. It's a cool show. It's a bit gruesome, but it's a cool show. And so, of course, we're not claiming to be dealing with all of these issues with what we're trying to do. But one key issue that this technology may help to tackle is the inability of banks to work together, to cooperate, and to exchange information with each other about the flow of funds. Because right now, necessarily any type of communication and exchange of information among banks requires exchanging of personal information or client-sensitive information, because all banks have to work with is the information on the users. And they cannot exchange that information easily, and that's exactly what criminals exploit. Now, what we're doing instead is we're saying, normally, if you look at the top, all we have to work with in transaction information is the information about the buyer and the seller, and if these happen to be customers of different banks, then banks cannot easily exchange that information with each other. And of course, if they in turn happen to interact with customers of even more banks, then that becomes even more difficult, basically becomes impossible. But what we try to do at Future Flow instead is to focus on the amount. So in this simple example, it's that amount 5. So in our case, that 5 is represented as a collection of 5 units. We want to track how these units move around the economy as they exchange hands. And as these histories get built, we can use them to assemble graphs, kind of conceptually speaking, that look like that little graph on the side. And what we argue is that what makes that graph interesting is not so much that we know the identity of each individual node on the graph, but rather the overall shape, if you will, of the topology. And in fact, this information can be fed to us by member banks in scrambled or hashed form. In this way, the personal confidential information of which bank entity client stays within the walls of the bank, but rather what we collect is the overall topology of how the flow moves around any selected party among the banks. And this way, this shared data set becomes a medium through which all member banks can communicate with each other and to signal with to each other what they know about specific parties without necessarily disclosing who each individual party is. All right, so basically this is to distinguish very quickly. This is a traditional approach of how banks think and work now. They go step by step, try to understand who is each individual node on the graph. What we're trying to do is to enable overall topology without necessarily caring about each individual node on the graph. So how does this all relate to Apache Beam? Well, I don't want to bore you with the details of how we're coming up with some of these numbers, but the slides that I was showing you here, these are the screenshots from our online demo, which deals with very small amounts. This is just the point of this demo, is just to demonstrate the intuition, if you will, behind what we're trying to do. But this stuff is written in simple SQL. You know, we're using Cloud SQL and we're hosting it in Google Cloud. It costs us probably £20 a month to run, actually less than that. But in real life, the magnitude of the data that we would have to deal with if we were to build something like this in real time and at bank scale is much greater. Again, I don't want to go too much through the details just for the sake of time, but just to give you an idea, if we were to build a system like this that were to work, let's say, in the UK economy, then we would have to have a data storage facility that should be able to handle something order of, let's say, 1 million plus database operations per second. And when I say 1 million plus, I mean probably somewhere between, let's say, 1 million and 5 million database operations per second. And of course, if we make it work, let's say here or in Australia or in Hong Kong, which are some of the markets that we're trying to tackle in the early stages of our development, we have to keep in mind that actually these economies are much smaller than some of the larger economies out there. So the UK economy is several times smaller, for example, the US economy. Or if you want to compare it with China, just like one simple statistic is just mobile payments in China, you know, between those two companies, WeChat and Financial, the volume of those payments clearing between just those two applications is 10 times greater than the volume of debit and credit card transactions in the UK. Right? So much bigger economies. So basically our challenge is to find a data storage facility that can handle that kind of load in the UK or Australia to start with, but also to be able to claim credibly and confidently to our potential bank partners that if we were to move to greater economies, to be enabling systems like this, then our system would be able to scale even larger from that, from those amounts. And we think that the system like this is Google Bigtable. So this is how we originally came to Beam. It was really through Bigtable. At first we started to look at Bigtable because, first of all, it seems like for that system it's actually no big deal to be handling these volumes of data. Second, we really like the fact that Google built Bigtable for itself and has used it in its own operations for almost a decade now. This is something that is very important in our conversations with banks because, to be honest with you, banks don't like new technologies. They like something that has been tried and tested in real life. And it's very good that Google's scale essentially serves, if you will, as a selling point for that. So that's an easy conversation for us. But of course, Bigtable in itself is kind of just a black box that doesn't do anything on its own right. You need to have something to work with this, and this is where we come to Apache Beam, or originally to Cloud Data Flow, which is what this used to be when we first looked at the issue a year ago. So what we liked originally about data flow, or now we'll call it Beam, is first of all, it's very easy integration with Bigtable. It's literally one line of code that puts your P collection into a Bigtable. Similarly, there's very easy integration with PubSub, which is Google's messaging service, or it could be an open source system like Kafka or something similar. This is actually very important for us because this makes it easy for us to tell banks that we don't need to do much in order to integrate our solution into their infrastructure. We can easily tell them that as long as they can put a message onto our queue about a transaction that is happening, then we can take it and take care of the rest on our side. So that makes the integration very easy. And again, from the Beam side, there's literally one line of code that takes a message from a PubSub or Kafka queue. Well, I haven't worked with Kafka, at least with PubSub, and Beam takes care of the rest. Autoscaling is an interesting feature for us because if these systems were to work in real time, there's a huge discrepancy between the volume of transactions that takes place throughout the daytime and nighttime. So it's nice to be able to adjust the number of workers dynamically. That's a cool feature. Finally, pipeline design. That's something that is very important for us right now because as we're still developing the use case, this is something that allows us to sort of take care of the beginning and the end of the project right away, and then focus on redesigning the actual business logic and the flow of how data actually gets transformed in the middle multiple times, because obviously we're not at a final solution yet. This is something that we'll have to keep reworking for quite a while. And with Beam, this is quite convenient because as you're constructing your pipeline, as I said, it's easy, it's nice to know that we've taken care of the beginning and the end, and what we're doing in the middle in terms of the actual business logic is something that we can tweak quite a bit as we're speaking with banks about how this use case will actually work. Just want to check how I'm doing on time. All right. So to give you an idea of the overall sort of high-level technology stack, essentially we want to take transactional data from banks that looks something like this, very simple, what we call flat format. You know, information on the buyer, the seller, and the amount. Obviously, in real life, we expect that data to be hashed so that we don't actually know who the buyers and the sellers are because we don't care. We just want to build the topologies around them. We push that data through our stack, which is the combination right now of, as I said, PubSub, Cloud Data Flow, which is the Google managed service for Beam, and Bigtable. Then there's an element of machine learning that I will go through a bit later. And what we want to come out at the end is basically the same information, but in a format that allows us to understand the flow. So the way we think about it is that this format is flow, this format is stock. This is stock versus flow. We want to enable the system that will help us to understand the flow of money just by giving you the information about the stock. Okay? So to give you a bit more detail about how this technology stack will actually work, by the way, so we have 3 banks there, HSBC, Barclays, and Lloyd. This is not to suggest that we're actually working with this bank, just a quick disclaimer, this is just to make this a bit more intuitive. We're not working with those banks. But the idea is that if we're working with, let's say, several banks, we want to have a PubSub queue from which we can read transactional messages from each of those banks. That gets read by the PubSub IO line in Beam. Then we have a transform that collects all of those messages into essentially one message pipe, and that gets into the core of the Beam pipeline. I tried to make this section to look like a pipe. Okay. And so at the end, all of that information will be stored in Bigtable. We have 4 core tables within Bigtable. I'll go through the details of what each of those tables does, and that serves as a storage facility for then various business applications to actually come in and read that data once it's put in the format in which we actually want to keep that data. And there are 3 broad categories of business applications that we want to be using on top of this data. Again, I will go through each of these 3 later, but just to give you a quick intuition, we need to be able to build simple and quick Python-based scripts that will be able to iterate and traverse through this data in order to find certain things. We'll go through the example of that later. Second, we want to be able to have a simple web-based interface that will be able to read that data from Bigtable and construct some of those graphs similar to the graphs that I showed at the beginning of the presentation. It's what we call sort of the last mile, if you will, solution that visualizes some of the linkages once the analysts are actually looking at them. And finally, we want the data that is stored in the Bigtable to be stored in a way that makes it very sort of machine learning, if you will, friendly. It needs to be in a format that enables training of various machine learning based models that will be doing some analysis of transactional data on the fly. So this is what our Beam pipeline looks right now. It's a little bit complicated just because there's some minutia here that goes into calculating some statistics of how many transactions we're processing per second or per a few seconds, etc. There's actually an element here of what we call a splittable DoFn. I know we're going to go through the splittable DoFns as they're done properly today at the deep dive, but we had to do this a year ago, at which time they weren't available yet, so we kind of had to fake one, thanks to some of the recommendations from Googlers on Stack Overflow. And as I said, we originally developed this in Dataflow 1.8 about a year ago, and then we recently upgraded this to Beam 2.2. So fortunately, it all works. There were a little bit of tweaks that we had to do, but generally, this works. Just check the time. Okay. So just because it's a little bit hard to read, and as I said, there are a few things here that don't really make any business impact. I created this. Whoa. What just happened? Sorry.
That's fine.
Sorry, I just gave you guys a very quick. Okay, here we are. So this is kind of a simplified representation of that same pipeline. Essentially, what we're trying to do here is read a message from a pub/sub queue, do something with that message, put the information in the table. Well, let's go through this in a little bit more detail. The core struggle here, if you will, or the key thing that we're trying to accomplish is to find some sort of a trade-off between parallel processing, which Beam does so nicely, but at the same time with the need to process transactions in some form of order. I mean, it doesn't have to be perfect order, but obviously processing a transaction that happened, let's say, in 2015, before a transaction that happened in 2010, is not cool, right? So we need to find some form of an order and make the best effort to process transactions as closely as possible to how they actually occurred. This is obviously relatively easy to do in real time, so as these transactions actually occur and they're being reported to us, if this actually works in production, in real time, then it's relatively straightforward. But if we have to do this in batch mode, where let's say a bank throws at us a stack of transactions for the past 5 years, we can't just parallelize them all together and process them all at once, right? Because that wouldn't make any sense. So that's why in both cases, what we're trying to do is push everything through pub/sub, and then essentially the trade-off that we're trying to achieve here is to say it's relatively easy for us to scan Bigtable, so we can do this sequentially, but it takes a bit more time for us to do the write and delete operations in Bigtable. So we try to sort of outsource that towards parallel processing. So essentially what happens here is we take each message from the pub/sub queue, and the logic here is, let's say, we take a message for a transaction for, let's say, between A and B for 10 pounds, right? And in our system, let's say we have a system that wants to track every single pound. So that means that we have to say, okay, so this is a transaction for 10 pounds between user A and user B. We have to go into our table and find all of the units, if you will, that are currently assigned to user A, select 10 of them, and reassign them to user B. So let's say we're in a situation where user A actually only has 6 units in our database assigned to them, not all 10. We have to trust the bank that that transaction is actually valid and that they had sufficient funds. So we have to build some of those units. So essentially what happens in this case is this element here, the parse transaction element, goes through Bigtable, finds the units that are assigned to user A. It's 6 of them, as I said. Those units are put out here into this big collection, where they will be further reassigned to the next user. Whereas the remaining number 4, which are the units that we haven't found because they don't exist yet in our database, they need to be created. So the other output element here is the number 4. So it's just one number, which suggests how many units we actually have to create and assign immediately to the recipient of this transaction. So that takes place here. This is, by the way, this has to be a splittable DoFn, because of course if the number is 4, then we can just loop through through 4 steps in the loop and create 4 units and reassign them to the seller. But if that number is 1,000,000, we don't want to loop through 1,000,000 from 1 to 1,000,000 and create those units in sequence, because that's not good parallelism. So here we want to split up that amount into smaller batches and process that operation in parallel. One of the interesting things here, by the way, is that in order to do this efficiently, we have to use 2 different ways to write into Bigtable. So as I said earlier, Beam is quite good in terms of integrating with Bigtable. There's literally one line of code that takes care of putting a collection of mutation elements into Bigtable, either as row updates or creations or deletions. The problem with this, however, is that in our experience, if we have to do this in lots of rows at a time, it's much better to do it as a buffered mutation rather than to do it one by one. And for that reason, we're using, so to go back here, we're using two different ways to write to big table. For very simple, quick writes that have to do with, let's say, one row at a time, we're using the native write to big table transform. But for the operations that by their nature involve very large collections, let's say 10,000, 20,000, 50,000 elements, it's much better to do that through a buffered mutation. And for that, Beam has a very nice abstract function from which you can, abstract class from which you can inherit. And this way, you can actually have a persistent, this allows you to keep a persistent connection to big table without reusing it, without reinstating it, and write a very large amount of either row creations or deletions to big table at once, and that really speeds up the performance. In our experience, this makes big table perform far better than the actual advertised, if you will, QPS that big table can achieve, given your node size, given your cluster size. What else to mention here? Oh yeah, so the interesting part here, again, this comes from personal experience, maybe we're not doing this right, but one of the issues here is that it's a bit unclear how Beam acknowledges the pub/sub messages. So, as you know, each pub/sub message needs to be acknowledged, otherwise pub/sub will try to keep resending it. And as you probably know, there's no explicit way to acknowledge a pub/sub message in Beam. And if you read the literature, by which I mean Stack Overflow, it suggests that the way the Beam pipeline acknowledges a message is when it's actually persisted in some sort of a persistent storage. So in this case, big table qualifies, seems like. But in our experience, it's much better to do it through here rather than through here, because here we're doing a bunch of different writes or deletes per message, whereas here it's one operation per message. So it seems like for our purpose, we do this once per message. This way, Beam more or less acknowledges that message, and then we're free to do whatever we want in terms of big table communication from then on. I think, let me just, for the interest of time, all right. So to give you an idea of how we're structuring some of our tables within big table, as you know, it's a NoSQL database, so there's no, we can just say select blah, 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 select the units that are currently assigned to user A, reassign them to user B. That doesn't work in big table. So in order to work around some of this, you have to be kind of creative in terms of how you design your tables, and especially how you design your row keys. So the way we're achieving this, which is very simple, but it seems to work for the most part for our purpose, is the key table here is this one, which is the map of users to units. So our goal is to say, let's say we have two users in the system, John and Peter. And we have 2 units currently assigned to John, and 3 units currently assigned to Peter. So what big table is good at is allowing you to find very quickly the users that are currently, the units that are assigned to a user, and then select as many of them as you want, and then reassign them to the next user. We can do this very quickly. And then the next thing that we want to do once that happens is we want to build the histories of how these units got reassigned. And for that, we have those two tables, which is a table which maps units to transactions in which they were involved, and also transactions to units which were involved in each transaction. This seems quite dumb because we're essentially kind of repeating the same information, which is very unfortunate. But from my personal experience, this is a better way to do this rather than storing information in columns. Because once you have a table with a table with a lot of rows, so let's say if you have a big table, in my experience, with let's say 1 billion rows, it becomes virtually unworkable to do a column scan. You really have to keep working with row scans. Row scans work quite quickly. Column scans, in my experience, don't seem to work very well. So, from my perspective, this is kind of a waste of space, but it works, and space these days is not very expensive, right? So, by the way, one thing that I haven't experimented with, I need to try to do this with regex scans, but I'm not sure if they would work as fast as row scans. I suspect they wouldn't, but it's one of the things that we haven't tried yet. And the ultimate goal here is to enable tracing like here. So essentially what we're trying to do is to be able to say very quickly, given the transaction ID, we need to be able to find all units that were involved in that transaction, but then for each unit, we want to be able to find all transactions in which that unit has been prior to the given transaction. That's why we have to go back and forth. And that's why we kind of have to duplicate this stuff, right? But it works, as I said. Where does this all go? How do we actually use all of this information? I told you at the beginning that I'll show you kind of three broad categories of things that we're hoping to achieve with this data. So this is one of them. So let's say we have a transaction. This is all we know about this transaction right now. If a bank is looking at a transaction like this is all they know. They know the buyer, the seller, and the amount. It's just one number. So the first thing we want to achieve is to say, actually, that number is not a number, it's a collection. So that 5 becomes a collection of 5 elements. Second, we want to say, for each of those elements, we want to know the unique history of that element, which is the information of all of the transactions in which that element was involved. And by the way, here, as I said earlier, we don't really care if banks tell us who are the actual entities behind these transactions. That's irrelevant. That's why banks can share this information. And then, since the banks don't have to share the entity information behind those transactions, they should be able to share some information about those transactions, which they actually feel comfortable sharing. So to give you an example, let's imagine that the yellow dots represent transactions that involve the so-called PEPs. So one industry jargon term is PEP, which stands for politically exposed person, right? So let's say the yellow dots mean PEPs. Let's say the blue dots mean, I don't know, suspected terrorists or something like that. And the red dots mean something completely horrible, confirmed case of something, which got revealed at some point. So as I said here, banks don't really need to share the identities of who those entities are. What they need to share is the information that can actually leave the walls of the bank without breaching any regulatory, data protection, etc. constraints. This way, we can immediately build a transaction score based on this information. Right now, banks can go until they're blue in the face trying to understand just those two entities, the entities that they're dealing with at a given transaction. This way, they can actually make a decision about any transaction by having the information about an arbitrary number of entities that were involved X number of steps back from the given transaction without necessarily knowing who those entities are. And then interestingly, as I said, let's imagine that the red dot represents a case that we really need to know about, right? Well, the neat thing here is that that's a unit, that's a transaction, right? So we said, so this unit has this history, right? Each of these dots is a transaction in which this unit was involved. And let's say this transaction is particularly interesting to us. Well, we can easily go in the system and check all units that were in that transaction together with ours. And we can say, well, now that we have those other units, we can go back and say, what are the transactions in which those units were involved that we didn't know about? Okay? And of course, I needed to make this very dramatic, so let's say that looks very dangerous. It doesn't have to. But the point is that once essentially your transaction serves as an entry point into the system, and once you have that, you can traverse through this data all day long until you find something that is relevant to you. This is why I said earlier, going back to the table schema design in Bigtable, we need to be able to very quickly find all of the transactions for any unit and all of the units for any transaction, because we want to be able to do this sort of recursively for any kind of situation. Let's see where we are. Okay, quickly. Next case. Once we know this, I just wanted to show this quickly, the intuition behind this in terms of how we actually build these topologies. One of the experiments which we thought really cool which was really recently done by TfL, is to understand the passenger traffic in a slightly novel way. So normally the way tube systems like TfL try to understand passenger traffic is in terms of stock, right? They try to figure out how many people get in at a certain station and how many people get out at a certain station. But recently the TfL did this study where they said, actually, we want to know not so much how many people get in and out between certain stations, but how they travel, what specific routes they travel to go from station to station. And as an example, they did this study where they tried to figure out how people travel between King's Cross and Waterloo, because this is one of the busiest sort of sections on the tube, and there's no direct route. So they tried to understand what people actually do, which specific lines they take. And they figured, okay, most of the people kind of do something straightforward and expected. This is what you would expect them to do. But actually, there's a whole section of people that does something completely crazy and unexpected. And once they discover this, by the way, they're doing this by collectively analyzing the anonymized mobile phone usage of people on the tube. So people kind of check in and out of various stations when there's Wi-Fi. This way they're able to build these tracks. And so once they saw this, they started asking questions like, why do some people, obviously a small amount, small percentage, But why do some people choose to travel this way, which seems to make no sense, right? Yeah, the point is, once you know this information, it really kind of draws your attention and enables you to start understanding what is going on. And we think that the same thing can be done with the data that we're assembling, but with money. Once you actually know, once you go back to a case like this, you start thinking, is this an accident that we ended up with some of the money from some of this really dodgy portion on the graph, or is there something systematic going on, right? That's the point. And we think that some of these visual components can enable the analysis like that. And finally, let's see how we are. Yeah, almost there. Very quickly, the third. I think we're out of battery. Finally, the third thing that we want to do with this data is essentially to build it in a way that will eventually be friendly towards machine learning and machine learning-based data analysis. So if you think about it, this kind of data is specifically suited for machine learning models that are based on long and short-term dependencies. So typical LSTM-style models which know how to maintain state and how to make decisions not just on the information that is available at each step, but on the information that is available from the history of number of steps back. Yeah, so we're basically trying to keep to design this data set in a way that will be easy or at least possible to be used by a system like this. Just for the interest of time, I'm not gonna spend too much time on this, but we can talk about this at the pub. Finally, just to wrap up. Yeah, in terms of where we are. So we as a company are currently in talks with 3 banks about potentially building proof of concepts on this. One bank here in the UK, one in Hong Kong, and one in Australia. Hopefully some of these conversations will succeed in the next few months. Very importantly for us, we have been selected into the FCA sandbox, which is the FCA's, if you will, exploratory environment that allows startups to work with banks in order to experiment with new technologies that benefit the banking or the financial system. This is a very important partnership for us because if we go back to some of those, what we're really hoping to achieve from this partnership is essentially to get some help from the FCA in building some regulatory framework around how to treat these histories. Right? We want them to help us to build an opinion on the fact that these histories of these units can be considered independent of the entities through which these units have passed. That's a key towards enabling banks to work together and to sharing this information. So that's a very important partnership for us. Yeah, basically one quick thing that I wanted to mention, which is also important here, is that this obviously right now, this whole solution is based within Google Cloud. That's great. Banks seem to be embracing the cloud. But for proof of concepts, it still remains easier for them to do some of this work in on-premises, in-house. And so it's actually quite neat for us that we can take all 3 of the core components of our technology and take the Apache equivalents of them and apply at least a test case of this technology on-premises before actually making everybody work in the cloud. All right, I'm going to stop here. Yes, thank you guys. And this is here for questions.
Check on the pointer.
Yeah, this one.
Are you fine doing?
Yeah.
Sorry about that.
No, I'm fine.
Thanks.
All right. Thanks, Vadim. For actually a good introduction about the deep dive we're going to do now, about the IOs and Beam details. I have a bunch of stickers, and actually I'm going to ask you some questions. And the good answer, you get stickers, or good question that you may ask, you will get the sticker as well. Yeah, I have a bunch. I have some Apache one as well. So during his talk, Vadim talked about IOs, big table. He talked about collection, data collection, and actually we're going to see what are these IOs. How you can write your own IO, what is an IO basically. Maybe some of you already know, but we're going to do some deep dive. We don't care about this. So quick remember about what is Beam. I'm going to ask some questions. so be careful. So the Beam parts, the programming model, and we will deep dive on VIOs and the file system. So Vadim talked about data flow. Actually, the important thing is Beam comes from data flow, but only one part of data flow, the data flow SDK. Data flow, there are two things. We have the execution engine, is what you are using on the cloud, and part of this data flow engine is the SDK, and this SDK became Beam. So it comes from Google Data Flow SDK. It's now on it's a top level project at Apache since, let me try to remember, May last year. After roughly 6 months of incubation, so if you're interested by how it works at Apache, I can give you some details about incubation process and all that stuff. The challenge of Beam is to provide a unified programming model. So it's exactly the same code that's going to address batch and streaming. And that's why the VIOs are really important. Because what defines if a pipeline is a streaming pipeline or a batch pipeline is VIO, nothing else. Okay? So that's why you have to understand how VIOs work. Portable. There's only one thing that I didn't understand in the Vadim's talk is about, he said we're going to switch from data flow to Beam on-premise. Yeah, but with which execution engines? Beam by itself does not provide any execution engine.
Sorry, I should have mentioned that.
Yeah. So today you are running with data flow, but locally on-premise, what should I use? Flink, Spark, Apex, JStorm, whatever. And this part, the portable layer, is made by the runner. We're going to talk about the runners as well. It's one tricky part of Beam. Okay, and extensible. And is where I would like to focus tonight. You can create your own IOs. It's pretty simple once you understood how it works. Okay? So, about the question. Do you remember the 4 questions of a Beam programming model? Who knows the 4 questions representing the programming model, the Beam programming model? No stickers?
What, how, where, when?
Yeah. And what does it mean?
Good question.
What? What is what?
So, one is to do
With an easy word. You know, pretty easy. What is what in the Beam model?
where are you trying
One word. One word. A function. What is a function? Are you doing sum? Are you doing, I don't know, group by key? Are you doing a window? Somehow? Okay, so what is the function? Okay, second one.
when in process.
Okay, so when, what is when?
Well, when event time. So,
Easier.
yeah.
A window. When means a window. Nothing more than that. I would like to group my data in a window, a chunk of data. Okay, the third one?
How?
How? What does it mean how?
So, is this
It's related to the when. I had
in processing time, where you sort of
So you're talking about processing time, I agree.
this is event time.
Or event time. That's the third. What's the difference between event time, processing time? Actually, it's the trigger. How equal trigger. Okay? So what function? When window. How trigger. And the last one? The where is the trigger. The when is the where is the window. The when is the trigger, and the how is the accumulation. Okay? So that's the 4 questions. What function? Where is the trigger? Where is the window? When is the trigger? And how is the accumulation? Okay? That's all that Beam is. So mixing all these questions, you can implement different use cases. The first one is just using function, you do batch. If you add some window, you do window batch. I don't talk about streaming for now. And if you do window plus trigger, then you have a streaming processing. And finally, you can do streaming plus accumulation. Okay? with just mixing these questions, you can implement different use cases. Yeah, you want to speak, right?
Yeah, I don't want to stick. I think I'm extremely new. I mean, in very basic terms and layman terms, what does Beam does? I mean, if you didn't have Beam, what would you have used?
Oh, that's a good question. Beam is a programming model. It allows you to implement, using a language, you have different set of languages. Using a language, you will create processing jobs. So Beam is a framework that you code. So you are doing some code, and you're gonna process a large set of of data. That's all. Only this is a data processing framework. Okay, that's it. So and this, what you're gonna do using this code is this.
So it's not a technology.
Programming model is a technology. Execution engine is a technology. So Beam by itself is a set of programming model implemented using SDK. So you have some languages you can use that allows you to implement this. Okay? And this is, thanks for the transition, this is the SDK that you have today. You can implement your processing job using Java, Python, or Go. Okay? You have also some DSLs, domain-specific language, on top of the SDK. So instead of using directly the SDK, because you are not very familiar with Python, or you are not very familiar with Java, I don't know, or you prefer Scala, I don't judge anything about this. Okay, so you prefer Scala, you prefer maybe SQL, you prefer XML, JSON, or whatever, then you can use a DSL on top of the SDK. So it's something that actually behind the hood, it will create the same SDK code. So when you use Shio, which is the Scala DSL from Spotify, behind the hood, you use the Java SDK. So whatever you're going to use, the Shio Scala DSL from Spotify or directly the Beam Java SDK will be exactly the same. Okay? And I said that Beam by itself does not provide an execution engine. So it means that you have to run your pipeline, what we name your data processing job. In Beam, we name this a pipeline. You have to run somewhere. And this somewhere is up to you. You can run locally on Spark, you can run on Amazon, on Spark located on Amazon EMR, on Google Dataproc, whatever. You can run on Dataflow, you can run on Flink, you can run on Apex, JStorm, or whatever. And the part that translates the Beam pipeline code that you wrote into something for the execution engine is the runner. So the runner is a translation of the code specific to one execution engine. For the ones who know Spark, for instance, the P collection, I'm gonna introduce what is a P collection, will be translated in Spark RDDs today. Pretty soon in data frame, but today is RDDs. Okay? So let's talk about the core concept. Pipeline, P collection, P transform, and we're gonna see what is a P transform. Who can explain to me what is a pipeline? In 3 words.
Series of functions?
Series of functions, I agree. And more specifically, what is a function in Beam?
Action.
What is a function in Beam?
Data in process, not data at rest.
The transformation. Transformation.
Yes.
Yeah.
A function in Beam is a P transform. So basically a Beam pipeline is a set of P transform. It's a chain of P transform. Okay? And you have 2 kinds of special P transforms in a pipeline. The first one and the last one. The first one, reading from somewhere. And the last one, storing from eventually to somewhere. Reading from somewhere is an I/O read. Writing to somewhere is an I/O write. So what do you think is an I/O? What is an I/O for you? is a P transform. An IO is simply a P transform. Okay? And the purpose of the IO is to read some data from some backend, PubSub, and create a P collection. What is a P collection in Beam?
It's a transformable collection.
Sorry? Say that again?
Transformable collection.
No, transform is a P transform. I'm talking about P collection.
Yeah, transformable collection. Not a collection where you can apply a transformation.
What is a collection? Collection of what?
Data.
Data. Okay, so why P collection? Yeah, pipeline collection parallel, be spread on different workers. Okay? Can I change a P collection? Yes, it's immutable. Okay, so a P transform actually take a P collection as an input and create another P collection as an output. Okay, the P collection is properly changed. And so a P collection is a set of elements, right? And what is an element, basically?
Can I ask a quick question?
Yes, go ahead.
What is the need of creating a P collection? So if I am having a data stream, data source, so if this pipeline is getting the data, why don't just fetch the data, process it, that's it? Why are we creating a P collection and then...
As soon as you have to transform the elements in the P collection, whatever you're going to do, you will do a transformation on the P collection. Let me take a concrete example. You read from Kafka.
I think I'm misunderstood. So what I am saying is, what I understood is like I am having a data source over here.
Mm-hmm.
I got a copy of that data into the P collection and then the P transformation happens.
Yes, correct. So you are reading from somewhere,
Yeah.
and you create a P collection.
So but that is a duplication of the data from the data source.
No, because let's take a concrete example. Back on Vadim example with PubSub. From a PubSub, I will have byte array of data, basically, when I read from a topic. Okay? This byte array will be paired into an element of a P collection. Okay? It represents what I'm going to transport in my pipeline. So it's not a copy of the data. Okay? It's just a population of the data in the element of a P collection. Okay? The purpose is really to wrap the data into a P collection. And I add Beam, actually the IOs, adding one thing for each element. Do you know the thing added for each element in the P collection?
Context?
No. Timestamp. By default, any element in a Beam, you will get the sticker like that. Any element in the P collection, by default, will have a timestamp. That's the default. And who do you think set this timestamp?
Apache system or you can.
The IOs. The IO decides how it's going to populate the timestamp. Is it, for instance, let's take JMS. I'm reading message from a JMS queue. Is it the time when I read the message? Is it the timestamp of the message? Is another timestamp? Is up to the IO. So the IO will decide what is the timestamp. Later I'm going to introduce the watermark, which is a different timestamp. Okay? All right? What do you think I need in each element of a P collection? If I have millions and millions of elements in my P collection, can I put this data in a single worker?
You need a key or something.
ID.
Key.
Now, key, that's the element by itself, but he said something very interesting, serializer. Serializer. It's not serializer in Beam. What's the name in Beam? A coder. So the coder is not about transforming an element to another kind of element. It's just how I can serialize this element in order to me to transport part of the P collection from one worker to another. So it's up to you to decide the coder you're going to use. It could be Java serialization. It could be Avro. It could be Protobuf. It could be whatever you want. Okay? So it's up to you. And who do you think define the coder?
The runner.
No. Two things. The P collection. So you can define, when you create a P collection, you can define each element in this P collection will use this coder or the IO. Because the IO populates the first P collection. So he has to define the coder as well. So that's why IO is pretty important in the pipeline. It defines a lot of context that actually you're going to use in your P transform, and your P transform will work thanks to the IO. Okay, so if I summarize, this is a pipeline, is a set of P transforms, as I said. You got the sticker, thanks to your answer. You read from an IO and you write to an IO. So a P collection is immutable, so you create a new P collection. When you consume a P collection, you create a new one. You have a timestamp, you have a coder, and you have two kinds of P collection, bounded or unbounded. Basically batch or streaming. And who do you think create this P collection and define if it's bounded or unbounded? The IO. And that's where Beam is really powerful, because without changing your code, without changing your P transform, just changing the first IO, the read IO, we will be able to switch from streaming to batch or from batch to streaming. Okay, I don't have to change anything. I mean, if you use Spark, you have to depend to Spark Core or Spark Streaming in the past and use different method and all that stuff. Not in Beam. In Beam, you just use different IOs. Okay? The P transform, I don't want. Oh, just one thing about P transform, which is very important. A P transform has to be serializable. For the same reason as an element in the P collection has to use a coder to be spread on the different workers, a P transform can be executed on any worker and can move from one worker to another. So in that case, it has to be serializable. Okay? This is the list of P transform you have. It's not complete, okay? It's just to give you some ideas. So it's the answer of the what question in the Beam prime model. Combine, sum, count, min, max, pardo, map elements, all this stuff is a P transform. So let's take a look on the IOs now. Let's start with the easier. Yeah.
Just a question on the previous one. If you want to write a P transform, which language are you going to write? In the runners?
No. That's a good question. Actually, so to give you a complete feedback, you write a P transform using, for instance, Java, and you package the dependency and you set in your pipeline. The runner API, which is part of the Beam core, is able, actually can create new transform based on primitives. So the only thing the runners has to do is to implement the 6 primitive of P transform. All of the P transforms are a combination of these primitives. If you create a complete new P transform that is not based on any primitive, then in the runner, you have to add the translation for this P transform. Translation meaning for this P transform in Beam, this is the translation in the execution engine. Okay? Most of the time, when you create a classic P transform, it will use the primitives, and so it will work in any runner. Okay? It's the same for the DoFn. Gonna see it later. All right? So let's move forward on the IOs. I don't know what time it is. Let's start with the easiest one, the write. So you have a pipeline, and you have a P collection. You did a lot of things like key value pairs of, I don't know, sum or whatever. And you want to store this P collection into a backend. How can you do that? It's two stickers for this one question. How can you do a write in your pipeline? Sorry?
A write IO.
Okay.
But depends where I want, right?
Yes. So basically, I have a P collection. And I would like, let's say, store in Elasticsearch. Okay? How can you do that? If, assuming I don't have Elasticsearch IO in Beam, of course, we have Elasticsearch IO. But I don't have anything.
I have that P transform of P done.
Exactly. And easier than that. So in the, I agree, you do P transform, P collection of string, P done. What do you do in the extend method of this P transform?
I have to.
Who said that?
Do a thing.
Yeah. The simplest write that you can do is just a DoFn. Why? I'm going to take each element in my P collection and store into something. Okay? And actually, all IOs today, the right part of the IOs, are implemented using DoFn. So this is a DoFn. Oh, it's not very. So it's exactly what you said. I have a write there, implementing P transform, P collection of string P done, and I have an expand where I call my write function. And what do I do in my write function? I use different DoFn annotation, like setup. In the setup, it will be called only once when I create my function. And in the setup, I create my REST client to the Elasticsearch instance. Then, in the process element, so in each element in my P collection, I will call my Elasticsearch client. So I will call my Elasticsearch. And then when I'm done, in the tier done here, I close my client. What do you think about this code? Is it good, bad? It sucks? It's written by a freaking French people. Sorry? It's serializable because DoFn is serializable.
Can you access stuff on the pipeline options?
Yes, you can in the pipeline. Actually, in the process element, you can access to the pipeline.
If you need, for example, an address for the Elasticsearch connection.
Yeah, most of the time in the IOs, what we do is in the P transform, we add some static method like a with Elasticsearch address, with blah blah, that actually we are reusing in the DoFn just to be able to contact the Elasticsearch instance.
Yeah, we tend to do that in the start bundle, and we access the options.
Yes, correct. And in terms of performances, do you think it's good or not? Do you think my Elasticsearch will behave correctly in that case?
What happens if they case of failures?
True. So what happens in terms of failure? In that case, I will have to redone the bundle. And here, I don't manage the bundle at all. So it means that I can lose some data. So in that case, instead of doing that, I can use bundle, start bundle, finish bundle. So like this, I can control my bundle unit. The size of the bundle is made by who? Who do you think defines the size of the bundle?
What's bundle?
The bundle is, I will give you the answer, is a group of data. It's not a window, it's a group of data. Just to simplify the way of transaction of the data. And who do you think defines the size of the bundle?
The collection.
No.
The runner?
The runner. Who said that? Second speaker.
Just guessing.
So yeah, the runner defines the size of the data. Okay? Let me take a concrete example. If you consider Flink, today in the Flink runner, the size of a bundle is 1. Okay? Yeah. On data flow, it depends on something else, but we're going to see just after. In Spark, is the size of a partition. Okay? So the runner defines the chunk of data it can process step by step. Okay? So I can introduce some failure management. But more than that, talking about Elasticsearch, do you think it's good for each element of the collection, I call my Elasticsearch? If I have millions and millions of records.
You can bundle up some requests and push them into Elasticsearch all at once.
Yeah, so instead of doing element per element, I can do batching. Okay? And to do that, it's pretty simple. It's exactly the same thing, but as Victor said, I can use start bundle and finish bundle, and I populate my batch. And then I don't call Elasticsearch for each element. I will call Elasticsearch for each bundle. So largely better because I manage the failure and I limit the overhead on Elasticsearch. Easy for the I/O write. Okay, all I/O write are made like this today. Let's talk about the read now. So the first thing is, for the read, you can use exactly the same approach. So to do a read, I can use a DoFn. So as we did a P transform of P collection of something P done, that time I will do a P transform of P begin, P collection of something. Okay? So this is a very simple function. Today, the JDBC I/O in Beam use this. Is a single DoFn. So in this P transform of begin P collection, I define my data source of my blah blah. And then in the DoFn, where I read, I create the connection to the database in the addSetup method. Then, for each element in the result set, I create an element in my P collection. So I have only a fake P collection in input. So the fake P collection is there. Create of nothing. So it's just a fake P collection just to start my DoFn. Okay, and the DoFn execute the query and populate the P collection. What do you think about this?
What if you lose your connection to the database?
Yes, in that case I don't have any data, you're right. But more than that, do you think it's performant? No. You're right, but I'm supposed to use prepare statement, blah blah, but regarding the I/O.
You just have one connection.
Yeah, more than that. Imagine, I have a database to Oracle, okay, with millions and millions of records that I would like to read. I'm not on cloud and on premise. With a Flink cluster of 1,000 workers. Do you think I'm going to use this 1,000 workers there? How many workers are going to use?
One.
A unique one. So it means that all read from the database will be performed on a unique worker. Okay? It's a DoFn. It's a DoFn with a create of void. So it's just on one worker and it do the result set, populate the P collection. What happened on the P collection, the P transform that I can apply on my P collection, will be spread on the workers, but the read by itself will be on a unique worker. So what I would like to do is not on a single worker, I would like to split the read on different workers. So instead of reading millions of records on one worker, I would like to read the first 1,000 records on first worker, the second 1,000 records on the second worker, extra. I would like to do the split. Okay? That's the purpose of a bounded source. So that time is exactly the same as a P transform, P begin, P collection of something. But that time we're going to implement two things. The splitting and the estimated size. So the splitting is really, I would like to create multiple sources. Each source is responsible of reading a chunk of data from the backend. Okay? Estimate size is the complete amount of data will represent petabytes of data. Who do you think is going to use this method, this estimated size? Vadim in his talk said, I like data flow because you do auto-scaling. Is what you said, right? He can create new workers, new machines. How do you think you're going to create new workers? Thanks to this one. Depending on the size of the data you're going to read, he knows how many workers you need to process this amount of data. Okay? So actually, this estimated size will be provided to the runner, and the runner can scale as he wants. To be honest, today the only runner that actually uses this estimate size is Dataflow Runner, efficiently. And a source is basically a factory of readers. So a source will read a chunk of data on one worker, and it will create a reader on this worker to actually do the read. So if I take a look on the code this time, it's basically the same. I have a P transform, P begin, P collection, and it creates a bounded source that time. And you can see in this bounded source I have the split method. You can see that this split method returns a list of sources. Okay? Each source is dedicated to a chunk of data. It can return a get estimated size in bytes, and each source can create a reader. So the reader doesn't have to be serializable because it will be local to one worker. The source has to be serializable because the source can move from one worker to another. Okay, especially in data flow, when you have, let's say, 10 workers, and one worker is faster than the others, so probably it will finish to read the data before the others. Then data flow can take chunk of the data that is supposed to be read by the first source and move to the other worker, just to balance the load. Okay? This source is a bounded source, right? Now I would like to read not from, let's say, Cassandra or Elasticsearch. I would like to read from Kafka or PubSub. It's not a bounded source there. It can be a bounded source, but so it means that after 10 messages, I'm done. It's not what I want. I would like to have a source already running and always running for a long time and consuming new message coming on. It's where we're going to create a bounded source that time. So it's exactly the same. P transform with a P begin, P collection of something. We're going to have the splitting and not estimation of the size, of course. Estimate size is only for bounded P collection. When you are in streaming, you don't know the size of the collection. But we're going to have three things that you can implement in your IOs. Watermark and timestamp. So as I said, timestamp is defined by the IOs. It's where you can do that. Who can explain the difference between the watermark and the timestamp? Nobody's used this? You don't use some trigger at watermark, for instance? Never?
It's a prediction when you think you receive all the events.
You said that before. You said event time and processing time. That's exactly what is the watermark compared to a timestamp.
It's heuristic.
Not always. It could be user. It could be user defined. I mean, it depends on the backend. It could be heuristic, as you said. It could be user defined. It could be accurate if you know. For instance, with JMS, it's pretty simple because you have the acknowledge. So since you don't send the acknowledge, you are done. Okay. So the watermark compared to the timestamp is actually the timestamp of all future data you may process in your pipeline. Okay. Checkpoint mark is about failure. You know that when you have a checkpoint mark, you acknowledge all the events, all the message before the checkpoint mark. Okay, so you have to create your checkpoint mark. For instance, using JMS or Kafka, in Kafka is the offset. You define the offset, and so the checkpoint is based on the offset. Dedup is to avoid deduplication of the data. If you consume multiple times the same record, that can happen in some backend. In that case, you define the record ID, and Beam is able to check if this record ID has been seen before or not. Okay? It's basically the same approach. So I'm doing a P transform, P begin, P collection. This time it's not a bounded source, it's a non-bounded source. You can see I have the split there. There. So the split is exactly like the same in the bounded source. It's up to you to define if you create multiple sources or not. Let me take a concrete example. If you know JMS? Okay. In JMS you have two destinations where you can consume message, topic or queue. If I use a queue, I can have concurrent consumer on this queue. So I can have multiple sources. If I use a topic, then I should use a unique consumer on this topic. So that's why the split can be different. Then I create the reader, I have my checkpoint mark. So it's where I store my message waiting to be acknowledged. So this is my checkpoint mark here. And here, this is my reader. And you can see in the reader, I have get current timestamp and get watermark. So anytime that I consume a message in the advanced method of my reader, I update the timestamp and the watermark for the current record. Okay, so you can create your own IOs like this. So what do you think about all these bounded sources, unbounded sources, DoFn, all that stuff? It's cool, it's not cool. Ah, you can see it sucks, it's bad. I have no problem with that. Actually, it's very powerful because you can implement splitting, watermark, and all that stuff, but it's not so easy to write IOs. Depending on the backend, it could be very tricky, and actually you have a lot of boilerplate code to write. And actually what most interesting feature there is the splitting. The fact that the source is not unique to a worker, but can be spread on different workers. I can have multiple sources. So to reduce the complexity of writing an IO, we introduced the splittable DoFn. It's basically a DoFn as we did for JDBC, you remember at the beginning? But instead of working on a single worker, I can define the split. I can spread my DoFn on multiple workers. And to do that, there are a lot of things that are really interesting. As first of all is, in the DoFn, we don't distinguish bounded or unbounded P collection. It's basically the same. The splitting is common to both bounded and unbounded P collection. Okay? And what we introduce is a tracker. The tracker is just to maintain the reader, to know where we are in the read. And the restriction defined, this tracker is located to this worker. If I show you a code, basically, my count function is a DoFn. You can see it's a regular DoFn. Okay? I don't extend splittable, DoFn, whatever. It's a DoFn, regular one. The only difference is in the process element, in addition of the process context, where I can get my element in and out, I have the tracker. The tracker, we provide a set of trackers for you, based on offset, based on record ID, but you can create your own tracker. Okay? And then, just using the tracker, here, I know on which sources I can work. Largely easier than writing a source. Okay? The good thing is, splittable DoFn are already there in the API. The bad thing is only supported by the direct runner. Because it's not so easy to write, actually, to update the runners to implement this. And we have to do that. It's not so complex, but it has to be done by the runners. So before you're able to use the splittable DoFn, first we have to support the splittable DoFn in all runners. It's not yet the case. It should happen pretty soon, more or less. We should also write the new, as soon as all runners will support splittable DoFn, then the new IOs we're going to create will be based on SDF, on splittable DoFn. And then eventually, step by step, we will rewrite the existing IOs to use SDF. Okay? So just to say that today, the API, you can already see the code in the API, the splittable DoFn with the tracker and all that stuff is already there. But actually, you cannot really use it. Because, or you can use only with direct runner, which is a very corner case. Okay? What time is it? Okay.
10:08.
Yeah. Do you want to see some stuff about the runners, or do you have any question? You want to get some stickers again?
Talk to me about Spark Runner.
Sorry?
Talk to me about Spark Runner.
Yeah.
When I get Python
No way. Today Python is on a specific runner.
It's not on the spot.
No. Today Python is only on a direct-like runner. You cannot run Python.
No, that's what I'm telling you. I'll get that.
Yeah, and Python you cannot run on Flink. It's not only Spark. It's any runner. Okay. It's part of a portability layer we are adding right now that will allow us to transform Python code into something executable, whatever the backend is. But it's not yet done. Other questions? Yeah.
I found tricky to TDD.
Sorry?
I found tricky to TDD.
TDD. What do you mean TDD?
I mean, test-driven development, right?
Why?
Because of the convoluted P-down, P-begin, all of that stuff. There are some methods which you are supposed to mock, right?
It depends.
And there are package private visibility, so you cannot do quickly.
So let me take a big example of the iOS answer. Of course, we are doing tests on the iOS.
Yeah.
Okay, we are using the test pipeline. So when you're using the test pipeline, so you can mock. Let's say you run with Kafka. You can mock your Kafka broker. Then you do in your test pipeline, you do read from, Kafka io.read.from zookeeper, blah, blah, extra. And you mock that part, or you create eventually a Kafka broker for your test. And then you use pipeline RCEP, to test your data.
Yeah, but I mean, it's not 100% for the code coverage, for example, that's not that great, for example, because you have object in the context by, for example, when you have properties or dependencies.
What context? Pipeline options, you mean?
No, when you execute the process element, you have the context.
Ah, okay, when you do fun, yeah.
Exactly,
Okay.
and you have also other parts that you want to mock in the same transformation and use creating the start bundle, then that's very tricky to do if you don't do via reflection.
It depends what part of a test. I mean, if you want to test a DoFn, for me, I do create of a P collection of something and I send to my DoFn.
Yeah.
And I just do a PR set after the DoFn just to check if the PR set match what I expect.
Yeah, and what if you want to do some verify on the mocked object?
What mock object? Which
I mean,
one?
if you have, for example, you said, okay, I have something which is transforming, right?
Yeah.
And I use a third-party dependency to do the transformation from A to B. And I want to verify that the object has been called twice or 30 times. Whatever.
So you do a mockito of this object.
Exactly.
Okay. And so
that bit, if you don't do a lot of tricky stuff and you use reflection, it's impossible to do and try different times. This is the first thing. The second thing is that the whole pipeline, if you want unit test, the whole pipeline is almost impossible.
why?
Because for the problem of I've been through the code lots of times, so lots of methods have package visibility, so you cannot extend, you cannot mock.
It depends what you, it depends what kind of test you want to do.
Yeah, I don't want to create any third party, for example, if I'm reading from PubSub and pushing to BigQuery, and I do not want to create a PubSub stuff, right? I want to just mock, say like...
If you use PubSub, for instance, when I do Google PubSub.read from blah blah, and you can do PubSub with PubSub service. And in this method, you provide your mock.
So there are some way to mock.
Yeah, the same in JDBC. In JDBC, you can do with JDBC service, and in that case, you don't use the data source. You're gonna use some mock that you provide to your pipeline. The only drawback of this approach, it means that the pipeline you are testing in the JUnit is not exactly the one you're gonna run because you change the option. You do with something.
Yeah.
That's the only drawback. But like this, you can mock. But I agree that it's not exactly the one you're gonna run. But you can test the whole logic of your pipeline. And you use the direct run. in that case.
Yeah.
That's the difference between unit test and integration test. Because unit test is always with the direct runner. I'm running out of time, so if you have any question, I can move forward on some slides, or I can answer to questions if you have. Up to you. Slides? All right, let's do that. So this is the list of the IOs you have today. It's a moving list. We're adding new IOs pretty often. So on the file system, one thing that maybe you see recently, for the one who read from a file system like HDFS, Google Storage, or whatever, maybe you use text.io, text.io.from, blah blah. So we change the way we manage the file system. So now text.io is based on files.io, which is a new method in a new IO in Beam. And the big advantage is now you can provide in the from when you are in the read or in the to when you are in the write, you can provide a URL like GES or HDFS or S3 or Azure or whatever. And this is dynamic, so it means that you can add new file system just by dependencies. So that's something we add in Beam 2.1, as far as I remember. It works fine. And it's something new. So today we have HDFS and Google Storage. We are working on S3 and Azure file system. So working with any kind of IOs based on files.io. So text.io, XML.io, CSV.io will happen pretty soon. The other IOs. MQP, Cassandra, Elasticsearch, all the Google stuff. So PubSub, BigQuery, Bigtable, HBase, HCatalog, JDBC, JMS, Kafka, Kinesis, MongoDB, MQTT, RabbitMQ pretty soon. The pull request is already open. I just have to complete it. Parquet.io is also a pull request release. Solar, Sika, XML. So this is the IO. If you need more, create a Jira. Sorry. The runners. Who knows how the runners are working? Who knows? Do you know how the runners are working internally?
So Spark is not great.
Why?
Maybe it's because of my crap code, but I use it on, I've got it on prem, that's the only way to do it.
It's funny because I did most of the Spark runner, but
I don't know, it's probably my code, right?
no. It's no. I'm kidding. There are some restrictions. Today, where I agree with you is the Spark runner is not optimal, maybe compared to if you do the Spark code directly, for two reasons. The first reason is we just updated to Spark 2, by the way. But we still. Sorry?
I couldn't get it to work with Spark 2.
It should work.
1.6, I think it was working.
I tested with 2.2.01 and it worked fine. So, but it's not yet complete, generally speaking, for the simple reason we still use RDDs. It's not based on data frame. So all optimization from Tuxen and all that stuff is not yet done. And for a simple reason, is because to be able to support data frame in Spark Runner, we need a schema. And in Beam, there are no schema enforcement right now. So that's why it's not so easy to map P collection element to data frame. So do you think you need a runner service running to be able to execute your pipeline? Do you think the same code, the same pipeline can run on Flink and Spark? And how would you do that?
If it's written in Java, yeah.
So assuming it's writing in Java. So I would like to have the same pipeline.
There's a matrix, right, of what's available.
And how do you define it's available in Spark, Flink, and Dataflow? In your pipeline, you create the pipeline using Java. Okay? And I'm a freaking manager, and I say I would like to run this pipeline on Flink or Dataflow or Spark. How do you do that? You can say fuck to a manager. It's what I do most of the time. But no, how do you do that? Sorry? How do you change the runner?
In the program arguments, -1 runner.
Sorry?
In the program arguments, -1 runner.
Without changing the code. So I'm manager. I say you have a pipeline. I don't want to change the code, but the same pipeline without changing anything, without recompiling your code, without rebuilding your pipeline. I would like to be able to run on Dataflow, on Spark and Flink. So change in the pipeline option, I can add --runner equal Spark runner. And what should I use to do that? What's the requirement to be able to do that?
Need two dependencies.
Exactly. So in your dependency, in your Maven project, if you are using Maven, you will have to add Spark runner, Dataflow runner, Flink runner. And then at runtime, you provide --runner on the Spark, on Flink, on Dataflow. So it means that there are no service or whatever. The runner is part of your jar. And the good thing with that is, if you use Spark, at the end, Spark doesn't know that the code has been created by Beam. I can submit my jar file using my Spark submit, as I'm doing usually. I can submit my jar file using Flink, as I'm doing usually. So the runner is a translation, but embedded in your jar file at the end. Okay, and that's the point. Yeah.
So it's actually this Spark execution that calls the runner, and then the runner, or how does it exactly work?
It's when you do Spark submit, then in that case he will see the Spark options if you want, and then he will call the Spark runner automatically. Okay. So it's really important to understand that there is not at compile time. Nothing is at compile time. It's a translation made at runtime, depending on the runner that you embed in your job. Okay? So this is the runners you have today. The first one is the direct runner. Is the one you are using when you do test, basically. Google Dataflow, of course. Spark, Flink, Apex, Gearpump, MapReduce is on the way, it's not yet done. Of course, it does only batch, no streaming. And JStorm, okay? If you want to create your own runner, it's pretty easy. You can do that. IBM published a couple of weeks or months ago, I don't remember exactly. They published a new runner they did for Beam, okay?
Were there benchmark tests?
No benchmark. Not at Beam, actually, for two reasons. Because first, it depends on the pipeline. Secondly, it depends on also the data and the setup you do. I mean, the tweak you do on the cluster and all that stuff. So we are very careful to not provide any benchmark at Beam, and we prefer to let the users do their benchmark. Okay? Something which is very important to understand is, of course, it's not possible to have a union of all features provided by these execution engines. So how we build the runner basically is not a union. So it's not all feature provided by all Spark, Flink. It's not possible. Okay. It's not an intersection. So it's not the common feature to Flink, Spark, and other, because it will be too, let's say, narrow. Actually, it is a kind of iteration and decision of a feature we want to provide for all runners. That's why on the Beam website, maybe some of you saw the capability matrix, is exactly because of this. It's not an union, it's not an intersection, it's some feature we think are the most interesting to implement for the different runners. Okay? So that's the purpose of the capability matrix. Is an iteration process. So we can extend the Beam model with additional feature coming from the execution engine, because we think it's really interesting. Or on the other hand, if we have some unique and interesting feature from the Beam model, then we try to push this feature into the execution engines.
There's also a difference between if it works or if it's performant. No?
That's different. The capability matrix is really it works or not. Most of the time, I mean, performance is a very tricky question. I mean, it depends a lot on the P-transform, it depends on a lot of things. But capability matrix is really yes or no. Okay. Just to show you a use case where I'm using different runners and file system and IO. So here when you see that I'm using file system and here I'm using the MQTT IO. And you can see that now, so this is all kind of bullshit. We don't care. The most interesting is there. So my pipeline, this is the first execution locally on the direct runner. I use my local Java JVM. So I do Java-CP just with the main. Exactly, so for instance, I consume from ActiveMQ for the MQTT message. It's actually a production use case, but we did. So here you can have some results. So you can see that this is the car located in some areas in France. I think this one is in France. Now I don't change my code. In the dependency, I just add the Spark runner. So I left the direct runner, I just add the Spark runner.
So what happens if, for example, this new runner doesn't support, I don't know,
That's a good question. You don't know before execution. So you're gonna probably scream because actually at compile time you don't know. It compile, everybody is happy, and when you run on Spark, crash. And yeah, today we are discussing about the validation step in the build to verify that the P-transform we are using in the pipeline are actually supported regarding the capability matrix. But today is not the case. So today you are using a P-transform that is not translated in the Spark runner. At execution, and only at execution, you will have no such method exception or pray for this translation one day or something like that. So this is the Spark runner. I do share exactly the same thing. This time I'm run, and you can see that here I'm using the regular Spark Summit. And you can see here, as Victor said, -- runner equals Spark runner. So I'm using Spark Summit. I specify the master of my Spark cluster is located there. And the option of this job, because it's a job for Spark, okay? There are nothing related to Beam. It's just -- runner equals Spark runner. And it's done. At the end, Spark doesn't know this code has been made by Beam. For him, it's Spark code. And if we drill down inside Spark, so here you can see I have dstream, Spark, unbounded source. So that's the translation made by the Spark runner. This is the translation from the different. So here you have a map. So it means that I use a P-transform, which is a map element of something, and the Spark runner translates this as a map. Okay? And now this time, in my dependency, I also define Flink. Okay, so I have Spark, I have Direct, and I have Flink. And that time, I can directly use the Flink dashboard. So again, when I do upload jar, it's a regular jar file. Nothing related to Beam. And so you can see here the translation made by the runner. So exactly the same code, without recompiling, without rebuilding, can be executed on different execution engines. And so the discussion we had with Matthias this afternoon was, let's say for your customer, or in your use case, you already decided to go with Dataflow, or you already decided to go with Spark. What are the value of Beam? That's a fair question. and I will answer the model by itself. Remember, watermark, all these features, they were not present in Spark 1, okay? But it was supported in Spark Runner. Okay, so it's all the feature you can implement and you can support using Beam, whatever the backend is. That's very important anyway. Okay? That's a lot of things, output. So to summarize. Oh, by the way, I have a question for you. Why in Beam we spend so much time of writing IOs that most of the time already exist in Spark, Flink, or Dataflow? I mean, if you want to read from Elasticsearch, you have an Elasticsearch connector in Spark. You have an Elasticsearch connector in Flink. Why writing these IOs?
Because they need to be portable.
First reason, it has to be portable. That's the first reason. It means that my pipeline, as I'm using Beam IOs, it can run on Flink, Spark, and Dataflow again. First reason. Second reason.
Where some only support the streaming and other ones fetch separately as well.
That's true. Yeah, some connectors only support specific use cases. You're right, and more than that.
Everybody uses them, it's a common use case.
I agree, but more technically speaking.
Splittable?
Exactly. All the features provided by the IOs, splitting, watermark, timestamp, coders, they are specific to Beam. So I cannot directly rely on the connectors existing on the execution engine because first, I'm not portable, plus I'm not supporting all the features that Beam can provide. Okay, that's why we spend time to provide the IOs in Beam. So just to summary on Beam, maybe you agree, you disagree, I don't know, we can fight with beers if you want after, but it's a unified model, first. It's exactly the same code for batch and streaming, with some advanced feature like watermark, splitting and all that stuff, checkpoint. Today we are a fairly number of connector, IOs, okay, it's not complete, but it's better than 1 year ago. Okay, we have Elasticsearch, Cassandra, and all that stuff. Agnostic, so it means that exactly the same code will run on different execution engine. Maybe it's not a very valuable argument for your business or managers or whatever, but it's true today. It's extensible. You can create your IOs, you can create your runners, you can create your DSL, your SDKs, it's up to you. And basically what we have in mind is for Beam, and one of the big reasons to have Beam at Apache is to be a kind of glue in the big data ecosystem. Okay, like this, we can integrate with different execution engine, different connectors, different language. So it's really the glue between all that stuff that simplify your use cases and allows you to implement very different use cases in a very flexible way. That's it. Do you have any questions? I still have a bunch of stickers, yeah? No question? Or discussion about Apache or whatever? No?
We're heading to the boat anyway afterwards, so probably if you want to ask Vadim some questions.
Yeah, sorry, I forgot the Q&A, guys. Obviously, I'm happy to take any questions at the pub here.
So yeah, any Q&A we can. We are heading to the Roundhouse, which is that way, close to Tesco. For the rest, I want to thank everybody for coming. I want the speakers especially thank them for speaking tonight. Keep in touch with these Twitter handles, email addresses. I will share the slides and probably the recording as well on the Meetup page. Then again, if there's any feedback or ideas, happy to hear. Datatonic is also hiring. We're hiring more than 20 people this year, so if you're interested, please reach out. And then, yeah, any Q&A, please join us at the pub, and we'll happily see you there and catch up with a beer. Thanks, guys.